Hello everyone, and welcome to the AI Research Roundup. I'm your host Alex, and today we're diving deep into one specific paper that's generating some buzz. It's called LHM, Large Animatable Human Reconstruction Model from a Single Image in Seconds. Basically, this research tackles the really challenging problem of creating a detailed, animatable 3D human model, using just a single 2D picture. The key goal here is to do this quickly and efficiently, generating high-fidelity avatars, including clothing details, in a matter of seconds. They propose a new model called LHM that uses, well, a multimodal transformer architecture and 3D Gaussian splatting to achieve this. Yeah, so looking at the first figure here, we can really see what they mean. It shows several examples. You get the input photo, and then bam, the reconstructed 3D avatar. They even highlight the speed, like just over 2 seconds for one example there. And importantly, you can see these aren't just static models. They show the avatars animated into various poses, demonstrating that animatable quality they're aiming for, all generated from just that single input image. It really gives a sense of the kind of results this LHM model can produce. So Figure 2 gives us a peek under the hood. It shows the actual architecture of this LHM model. Basically, it takes that single source image we saw before, and also uses a standard 3D body template called SMPLX to get some initial geometric information. It then extracts features from the image, using separate processes for the head and body to capture details properly. These image features and the 3D geometric info are fed into the core of the model, this multimodal body-head transformer, which fuses everything together. Finally, it decodes this fused information into that canonical 3D Gaussian model we saw, which can then be posed and rendered. Okay, so building on that overall architecture, Figure 3 zooms in even further, showing us the details of one specific component, the multimodal body-head transformer block, or MBHT block. Remember we talked about the head and body features being processed separately, then fused? Well, this block shows how. You can see it takes in the 3D head query tokens and the 2D head image tokens, which are actually randomly masked sometimes, and processes them first. Then, that result interacts with the 3D body query tokens and the 2D body image tokens in a second step. It also shows these, quote, global features influencing the process before outputting updated tokens. Okay, so moving beyond the architecture itself, Figure 4 really drives home the performance of LHM by comparing it directly against other existing methods. You can see the input image on the left, and then reconstructions from methods like GTA, Sifu, PS Human, Dream Gaussian, and finally, the LHM result labeled Hours. It's pretty clear visually. LHM seems to do a much better job capturing the overall appearance. The texture details, look especially at the faces and the wrinkles in the clothing. They look significantly sharper and more realistic compared to the others. Building on that visual comparison, Figure 5 specifically looks at the animatable aspect. So while the last figure compared static reconstructions, this one shows how LHM performs when the generated avatar is actually animated into different poses. It compares LHM labeled Hours against another method called AniGS, this time using in the wild video sequences. You can see the models put into various action poses, and again, the LHM results appear more accurate and, well, more photorealistic in these animations compared to AniGS. So we saw the visual comparisons for static reconstruction back in Figure 4, and Table 1 here gives us the hard numbers behind that. It evaluates the static 3D reconstruction quality on synthetic data, comparing LHM against methods like GTA and Dream Gaussian using metrics like PSNR, SSIM, and LPIPS. And, well, LHM significantly outperforms them. Its PSNR is way higher, over 25 compared to around 18 for the next best, and its LPIPS error is much lower too. So these metrics confirm that LHM produces quantitatively superior static reconstructions. Right, and following up on those quantitative results, Figure 6 gives us a visual sense of why LHM performs so well, specifically looking at model design choices and the impact of model size. It compares a result using a more standard multimodal transformer on the left, with the LHM model at 0.5 billion parameters in the middle, and then the 1 billion parameter version on the right. You can really see the difference, especially in the zoomed-in details on the face and the shirt graphic. They get progressively sharper and clearer as we move from the baseline to the larger LHM model, suggesting both the LHM architecture itself and scaling it up contribute to the better quality. So yeah, those model comparisons really highlight what LHM achieves. The big picture here is getting high-quality, animatable 3D humans from a single image and doing it incredibly fast in just seconds. This kind of advancement, well, it significantly pushes the boundaries for creating digital humans, which is super important for areas like VR and gaming. That wraps it up for this week's AI Research Roundup. Thanks for listening. I'm your host, Alex.